Hello friends, let us study examples on sampling. The example here is a die was thrown 9,000 times and a throw of 5 or 6 was obtained 3,240 times. On the assumption of random throwing, do the data indicate an unbiased die? So die is thrown 9,000 times, that is our experiment, and it was seen that uh, 5 or 6 appeared 3,240 times. Now, does this indicate that the die is unbiased? That is what the question is. Now, hypothesis that we assume is the die is unbiased. Always the hypothesis should be on the positive side. So we'll assume that the die is unbiased. Now we have the experiment is repeated 9,000 times. So n becomes 9,000. Now p is the probability of success. Now success is here obtaining 5 or 6 when the die is thrown. So probability of getting 5 or a 6 with one die. So here 5 or a 6, two favorable cases are there. Total possibilities when a die is tossed is any number from 1 to 6 can appear. That is total possibilities is 6, and favorable cases are 2. So the probability of getting 5 or 6, it is 2 by 6. That is we have 1 by 3. Now expected number of successes. Suppose this is the probability that we get success on one throw, then out of 9,000 times, what is the probability that we get? That is how many times we can expect success. It is n into p here. 9,000 into 1 by 3, we get 3,000 here. So that implies we can expect that out of 9,000 times, 3,000 times we will get success. But what is given here is experimentally when it is done, it is observed that 5 or 6 have been obtained 3,240 times. So observed number of successes is 3,240. Now, this observed number of successes is denoted by either x or sometimes x bar also. And mu, it is the expected number of success, it is 3,000. And we'll write the value of z here. Z is x minus mu divided by under root npq. Mu is nothing but np here. So x, that is 3,240 observed number of success. Mu, that is np, it is equal to 3,000 divided by under root n 9,000. P is 1 by 3. If p is 1 by 3, q becomes 1 minus 1 by 3, that is 2 by 3. Simplify this, the value we obtain is 5.4. Now this value we can see is much greater than 2.58. Hence the hypothesis is to be rejected at 1% level of significance, because the value is too much greater than our value at 1% level, that is 2.58. Hence we conclude that the hypothesis is rejected, means the die is not unbiased, it is a biased die. The die is biased. That is our conclusion. Let us see one more example. A sample of 900 members is found to have a mean of 3.4 centimeters. Can it be regarded as a truly random sample from a large population with mean 3.25 centimeters and standard deviation 1.61 centimeters? So a population mean here is 3.25 and standard deviation is 1.61 is mentioned. Now from this population a sample of 900 members is taken and is found that the mean is 3.4 centimeters. Can this imply that this sample belongs to the same population? That is the question. Now uh, we need to write the hypothesis, or we can consider it as there is not much difference between the mean of the sample and the population, or we can even write that the sample can be considered from the population only. That will be the hypothesis. We can regard the sample as a truly random sample from a population, larger population. That is will be our hypothesis. Now n is 900 here. X mean of the sample, it is 3.4. Mu mean of the population, it is 3.25. Sigma value is 1.61. Now Z is x minus mu divided by sigma by root n. Now calculate this, simplify it, we'll get Z as 2.8, which is greater than, you can see, 1.96, that is for 5% level of significance, as well as it is greater than 2.58, that is for 1% level of significance. Thus, under both 5% as well as 1% level of significance, we reject the hypothesis. That is, the sample cannot be regarded as a random sample from the large population.